Yeah, welcome. This session we'll talk about the GATE 2020 set to question 29. Okay, so just going through the question. The planar structure RST, this is a structure given, RST, is roller supported at S. So this support is roller and support R is pin, support R is pin, and members RS and ST have uniform flexural rigidity, same EI values, and S is a rigid joint. This is a rigid joint. Consider only bending deformation and neglect effects of self-weight and axial stiffening. Okay, then the question is, when the structure is subjected to concentrated horizontal load P at T, the magnitude of rotation at support R is how much? These are the options. And so the solution that if you work out will be PL square by 12 EI. Let us go through what are the concepts involved in this question and how we solve this one. See, the load is here, whereas you have asked for the rotation of this point. Okay, the rotation of R, how much? Okay, so I'll transfer this load from this point to this point. Okay, I can transfer this load onto this point by the principle called principle of superposition, by superposing an equilibrium force system. Okay, so you add a force system which is in equilibrium. So these are the two forces which are acting at point S. Okay, so the force values are P and P. See here, I am adding nothing, 0. P minus P, 0. Okay, so I consider an equilibrium system which is superposed here. Now you see, this force I want to transfer here. So this I require here. Okay, then what about the remaining two forces? See, they are equal and opposite. Okay, and separated by a distance L by 2. So they form a couple, and that direction you see, it is clockwise. So it is a clockwise couple. Okay, so now this beam, what you see it here, roller, now has an axial load of P and a clockwise momentum of value force into distance PL by 2. Now this is the beam RS for you. Okay, as it is said that axial stiffening is to be neglected, so we neglect the deformations from this axial load to the beam, right, to this member RS. So now you know this is a simply supported beam applied by a moment of PL by 2 at S. What is the rotation of this point? So if you draw the deformed shape, you see this beam is going to deform like this. Okay, so this is how it is going to bend because of this moment. So this is how it is going to rotate. This point is going to rotate in anti-clockwise direction. That is theta r value. Okay. So what is theta r value? You know, when a simply supported beam is applied by moment at one end, the slope at the other end is equal to ml by 6 ei. Okay, and the slope at this end is ml by pei. So this is from your structural analysis knowledge. Okay, now what is m value? It is pl by 2 moment l divided by 6 ei. So this works out to pl square by 12 ei. Okay, so that is your answer, right? So here you see the concept of force transfer from one point to the other point where it is not on its line of action. This you have studied in engineering mechanics, and principle of superposition you are using. Okay, and then the structural analysis part, where the simply supported beam, if one end of the beam is applied by a moment, what is the slope at the other end of the member? That is the question, right? So your answer is PL square by 12 EI. Thank you.